Docker Volumes Deep Dive. Containers are temporary by design. Data stored inside containers can be lost. Docker volumes provide persistent storage. Volumes are essential for production applications. Why storage matters. Applications generate important data. Databases store business information. User uploads must be preserved. Losing data can cause serious problems. Understanding container storage. Every container has a writable layer. Applications can create and modify files. Data exists while the container exists. Container storage is temporary. The container data problem. Example. Create a file inside a container. Stop and remove the container. The file disappears. This behavior surprises many beginners. What is ephemeral storage? Ephemeral means temporary. Container writable layers are short-lived. Data may disappear when containers are removed. Not suitable for critical business data. Why persistent storage is needed. Applications commonly store customer records, orders, product data, user uploads, application settings. This data must survive container changes. What is a Docker volume? A Docker volume is managed by Docker. Volumes store data outside containers. Data remains available after container deletion. Volumes provide persistence. Understanding volume independence. Container deleted. Volume remains. Data remains. Volumes are independent of container lifecycles. Real-world example. MySQL database container. Stores. Customers. Products. Orders. Without volumes, data may be lost. How volumes work. Container. Application writes data. Docker volume. Host storage. Docker manages the storage location automatically. Benefits of Docker volumes. Persistent storage. Easy management. Better reliability. Improved portability. Production ready. Creating a volume. Command. Docker volume create myVolume. Creates a named volume. Ready for container use. Managed automatically by Docker. Listing available volumes. Command. Docker volume ls. Displays. Volume names. Storage drivers. Available volumes. Inspecting volume details. Command. Docker volume inspect myVolume. Provides. Volume name. Mount location. Driver information. Metadata. Mounting a volume. Command. Docker run v-myVolume/app/data Ubuntu. Docker connects the volume to the container. Understanding volume mapping. Docker volume. myVolume. Mounted path. /app/data. Applications access data through the mounted path. Writing data to a volume. Application creates. /app/data/report.txt. Docker stores the file inside the volume. The file survives container removal. Persistence demonstration. Step 1. Create volume. Step 2. Run container. Step 3. Create file. Step 4. Remove container. Verifying persistence. Step 5. Start new container. Step 6. Mount same volume. Step 7. Read file. The file still exists. Named volumes. Examples. Database storage. MySQL data. App logs. Benefits. Easy identification. Easy management. Easy reuse. Anonymous volumes. Example. Docker run v/data Ubuntu. Docker automatically creates a volume. Names are generated automatically. Named versus anonymous volumes. Named volumes. Easy to manage. Reusable. Recommended. Anonymous volumes. Auto-created. Harder to track. Temporary usage. Sharing data between containers. Container A. Shared volume. Container B. Both containers access the same data. Real-world shared storage. Web application container. Shared upload volume. Background processing container. Both services access uploaded files. Volume lifecycle. Containers can be deleted. Volumes continue to exist. Data remains available. Volumes require explicit removal. Viewing storage usage. Command. Docker system df. Displays. Images. Containers. Volumes. Build cache. Removing a volume. Command. Docker volume rm myvolume. Warning. Delete stored data permanently. Use carefully. Cleaning in used volumes. Command. Docker volume prune. Removes unused volumes. Freeze disk space. Should be used cautiously. Common volume use cases. Databases. User uploads. Log files. Shared data. Application configurations. Database example. MySQL container. Volume. Persistent database files. Database survives container replacement. Application logs example. Application container. Volume. Persistent log storage. Logs remain available for troubleshooting. Volume best practices. Use named volumes. Backup important data. Monitor storage usage. Remove unused volumes. Secure sensitive data. Common beginner mistakes. Storing important data inside containers. Forgetting to create volumes. Accidentally deleting volumes. Confusing volumes with bind mounts. Production recommendations. Always use volumes for databases. Backup critical information. Monitor storage growth. Document storage requirements. Test recovery procedures. Key commands recap. Docker volume create myvolume. Docker volume ls. Docker volume inspect myvolume. Docker volume rm myvolume. Docker volume prune. Key takeaways and lesson summary. Container storage is temporary. Volumes provide persistent storage. Volumes survive container deletion. Named volumes are recommended. Volumes are essential for production Docker deployments.